15. Okay, we'll just try 15 to start with. 15 is it a simplification or what is it? Yes, it's negative 3w to the 5th times 9w to the 3rd. Is that what it?
Yeah, I just didn't.
Okay, so what can you multiply the negative 3 by? What does a pair? 9. What's negative 3 times 9? Negative 27. So we have negative 27. What are the like terms here? We have w to the 5th and w to the 3rd. W to the 5th times w to the 3rd. What do you do with the exponents? So it's w to the 8th. All done. That's it. That's it. You're done. There's nothing else you can do. There's nothing else to do. As another friend evaluated, what is it? 6 to the 5th over what? 3 squared as 2 to the 3rd or 8. What went wrong? Well, first of all, can you simplify this straight off by subtracting the powers? No, because they don't have the same what? Base. They do not have the same base. So if you wanted to simplify this, you would have to have the same what? Base. So what did they do here? They just divided 6 by 3 and subtracted 2 from 5. Are you allowed to do that? No, you have to have the same base. You can create the same base. You can transmute this a little bit by keeping the same value. What's a way you can rewrite 6 so that it contains a 3? No. What? 3 times 2. So you have 2 times 3 to the 5th over 3 to the squared. Look at the numerator here. What can you do with that power of 5? Yeah, you literally kind of distribute it to the powers, not kind of. So it'd be 2 to the what? 3 to the all over. Now, do you have a common base pair? What's the common base? You have this. So what's this going to be? 2 to the 5th times 3 to the 3 to the 3rd. Stop there. Is that a lot bigger than 8?
Yeah.
Yeah, what's 2 to the 5th? 4, 8, 6. That's 32 times greater. Actually, bigger. Sorry, it's 3 to the. It's actually bigger than that greater because it's 3 to the 3rd. So is that equal to 8? No. You have to have the same base to subtract the powers. So the question is, okay, you accept that as a rule, but why is it the case? You accept those. Okay, so let's actually see that. Hang on, if I do that, the first quadrant. So look, there's 2 to the x, and here is 3 to the x. One of them steeper because as you raise 3 to a power, is 3 squared greater than 2 squared? Yeah, 3 to a power after 0 is going to be greater. So let's actually change the window just a little bit more. Let's go to x max of 1 and a y max of 1. So I'm just zooming in more around where it crosses the y-axis. Where it crosses the y-axis. So let's graph it again. So all I'm doing, I'm not graphing a new function. Oh, I need to make it a little bigger. Sorry. Let me pause this for a sec. Down here, I'll put this in. So if I label each of these, this is 2 to the x, this is 3 to the x, this is 4 to the x, and this is 5 to the x. What do you notice about each of them? They intersect where? The same place, right? What point is that? 0, 1. They all intersect right there. They all intersect right there. So when you plug in 0, what do you get out? 1. So what is that telling you? 2 to the x when x is 0 is 1. So 2 to the graphically, I'm just giving you another way to believe this. So this graph is telling you 2 to the 0 is 1. It's telling you that 3 to the 0 is 1. 4 to the 0 is 1. 5 to the 0 is 1. Based on these graphs, is there anywhere else where they intersect? Just as a side question. Does it look like they intersect anywhere else? No, they don't. That's just another way to believe it if you want to. We'd have to get into fractional exponents to do any more explanation, and we're not quite there yet. We'll get there soon. Because look, if you want to get really close to 0, you're less than 1, right? So it could be like 3 to the 1/3 power. That's the cube root of 3. 3 to the 1/billionth power. 1 over a billionth power. We have to use fractions. We're not there yet. What the first one is?
8.2 times 10 to the 4th.
Yeah, who agrees with that? Nice. Rachel, what about the second one?
I do.
Anybody get the second one?
I did.
Lauren.
7.2 times 10 to the -6.
Yeah, let's just count that. 1, 2, 3, 4, 5, 6. Excellent. These two numbers must be what?
1 plus 1. In between 1 and 10.
Yeah, you have this written in between, and they could be negative. It's fine. But the absolute value is between 1 and 10. If it equaled 10, what does that mean you could do? Or if it was, yeah, if it equaled 10, what does that mean you could do? 1 times add 1 more to the power. Exactly, good. Okay, so let's just get
4.05 times 10 to the 12th.
Who got that right there? 4.05 times 10 to the 12th. You plugged it into your calculator and just it spat out an answer. Is that? I mean, that's fine. Is that how you did it?
Yeah.
What did it write when it gave it to you on your calculator? What?
4.05
E12, exactly. What does E12 mean?
10.
Exactly, times 10 to the 12th, exactly. Very good, that's what I wanted to make sure you know. Excellent. Two definition of a polynomial, which is good because kind of the technical definition of a polynomial is overly wordy and complex. A polynomial in terms of it is a term or a finite sum of terms of the form, a term is a finite sum, so that's kind of redundant, of the form ax to the n, where a is a real number and the exponent n is a whole number. What are some of the most important words in that definition there? What are some of the most important words? Real number, that's one of them, absolutely. So one thing that's super important is the fact that what has to be a real number? A has to be a real number. And then what's the other thing that's really important in here? Whole number, and where's that? That's n. So what's not a real number? Do you know? Can you give me an example of something real that's a number that's not real? Square root of negative 2 would be 2i, root 2i, right? If you have I in your coefficients, that's bad. But anything else is okay. So for example, is this right here? Is that a polynomial? Pi is a real number and 2 is a whole number. Can you give me a number that's not whole that might be close to being a whole number? 7/8. Sure, that's not a whole number. What's another example of something that's not a whole number? -6. That's not a whole number because whole numbers have to be what? Positive. Is that correct? Do you remember that first week? Whole numbers have to be positive. Is that correct? Whole numbers? No? So can we have a negative exponent? What is a whole number?
0, 1, 2.
Ah, okay. So whole numbers are the set 0, 1, 2, 3, 4. What's the smaller set? What's the set that lives inside there? Do you remember? What are those called right there? Natural numbers, remember that? Yeah. And then what are the positive and negative whole numbers added together into one? Nope. If I have negative and positive whole numbers, what do I have? That's called the integers. The integers. You know this, if you think about it in stages, it's fine. So the number one mistake when you're writing a polynomial, it's really important that you do what? Descending powers, and everything is simplified as far as it can go. So this word, descending powers. So what are the descending powers? What's the highest power of that of the terms in that polynomial? For this right here, yeah, for this one. 5. That's the power. So it's this is a 5th degree polynomial. What are the two? What's the first kind of segment in this word? What's the first piece of that word? Poly. And what's the second part? Nomial. What does poly mean? Many. And nomial, I think it's piece. I can't remember exact definition, but the idea is that many pieces glued together. And what's the glue that binds the pieces together? No, the pieces are fused by multiplication. Adding and subtracting, exactly. So the only operation you can have here is adding and subtracting, exactly. Okay, number of terms. 3 terms, 2 terms, and 1 term. Can you have lots of things glued together with multiplication in 1 term? Yeah, you could have just 7, or you could have 5x cubed y to the 7th. How many terms in each case are there? 1. Just 1, just 1. So you see? Yeah, this is a monomial. What about C? Binomial. D? Quadromial. We like that. Oh, wait. Is there anything that can be simplified? Yeah. You sure? Yes. What? You can't. You can't do that because it's subtraction. They're different. They're not like terms. So how many terms are there? There's 4. So quadromial. I like that. What about this one right here? Can any of these terms be combined? Yes. Yeah. Which ones can be combined?
5x squared.
And so what do they combine to be?
45.
14.
Oh, 14, sorry.
14 what?
X squared 4.
No, it's not multiplication. You are adding them. So you have 5 of them and 9 of them. 5 apples plus 9 apples is 14 of them. And then what about these two? Can these two be combined? What do they combine to be? Plus 7x y xy squared. So how many terms are there? 2. So what would this be called? Binomial. Exactly. So it's important that you can verbally express them. Okay, everybody stand up. Let's clean this up. I got 2 to the negative 1, m to the negative 3, x to the negative 2, 3 to the negative 3, m to the negative what? M to the negative 12, x to the negative all over, m to the 6th, x to the 9th, m to the negative 10, x to the negative 5th. That's all multiply. You just got to combine them now. M to the negative 3 and m to the negative 12. What does that become? Yeah, that's on tape too. M to the negative 15. What about x negative 2 and x to the negative 3? X to the negative 5th. And then you just have, you can pop that 2 down below and that 3 down below too. Well, I'll keep it up there. It's fine. 2 to the negative 1 and 3 to the negative 3. What at the bottom? M to the 6th and m to the negative 10. It's going to be m to the what? M to the what? Negative 4 and x to the 4th. So now you have to match these up. That's going to be m to the negative 15 minus negative 4. Hold on, negative. No, it's not quite. X to the negative 5th minus 4, right? We just took care of that one as well. And then what does that get multiplied by? 2 to the negative 1 and 3 to the negative 3. What is negative 15 minus negative 4? Negative 11. And that's x to the negative what? X to the negative what? What does this simplify to? We don't like negative exponents. What does this become? 1 over, kids, pay attention. Ah, m to the 11th.
2, 3.
There it is. Done. Okay, kids, get out of here.